All right, so yesterday we went over some stuff about ionic compounds. So just a quick review. Okay, an ionic compound is made of two things. What are they?
A metal and non-metal.
Metal and a non-metal. Okay, so one thing from the left-hand side of the staircase, one thing from the right-hand side of the staircase. Okay, ionic compounds form because of an ionic bond that involves the trading, essentially, of electrons. A metal will give up its electrons, and a non-metal will take them, okay, filling their outer shells, making them happy. Okay, those ionic bonds are very weak, however, because of course once the outer shell of the atom is full, okay, they don't really need to stay together anymore. Okay, so those bonds break very easily. That's essentially what we went over about ionic compounds yesterday. Okay, then we talked about some review stuff in terms of how to name an ionic compound, a simple binary ionic compound, right? And that is that you name the metal first, and then you name the non-metal second, and the non-metal ends in "ide." Okay, that's really all we need to know. Do the numbers on the compound, like this one here, okay, where it's CaBr2, do we reflect that in the name at all?
No.
No, we don't. Okay, because of the swap and drop. There's only one way bromine and calcium can go together. Everybody knows that, so we just have to say calcium bromide. All right, everybody with me on that? Okay, then let's go over these two together just to review. Okay, or did we do these two? We got that far, didn't we? Yeah. Okay, let's look at 7 and 8 then. All right, so on number 7, I've got Na, which is sodium, with oxygen. Okay, there's a 2 here, but again, that's not going to matter. There's only one way that sodium and oxygen can go together. That's that way. Okay, this stuff would be sodium oxide. And remember that that 2 is there because oxygen has a -2 charge and sodium has a +1 charge. Okay, so when we drop and swap those numbers, that makes sure that we have the same number of positive charges as we have negative charges. Okay, this oxygen has a charge of -2. Every sodium has a charge of +1, so I need 2 of them to account for the 2 negative charges that oxygen has. You'll give that idea. Okay, the compound always has to be charge balanced. All right, and then for number 8, I've got barium with selenium, so this will be barium Selenium. Okay, and again, this one is already charged balanced because selenium is a -2, I believe. Yeah, and barium is a +2. Right, those already cancel each other out. Everybody following? I want you guys to try those ones there, and we'll go through them together in a couple of minutes. All right, so for number 9, okay, we've got radium. Okay, that's our metal, so we just name it as it appears on the periodic table, and it's with tellurium, okay, so we name it telluride. So this is radium telluride. Okay. And then for number 10, we've got lithium as our metal with fluorine, so this will be lithium fluoride. Okay, if you got questions on these as we go, don't wait for you to ask, guys. And for number 11, we have rubidium with sulfur. So that'll be rubidium sulfide. Okay. And for number 12, we have strontium iodide. Okay. Questions on any of those? Okay. Hopefully those seem kind of familiar. That's the kind you would have done in Science 2, or in Science 9, sorry. Okay. All right. Now, we're going to move on to something that's new with ionic compounds that you wouldn't have done in Science 9. Okay? And that has to do with what we call multivalent metals. Okay? There are certain metals on the periodic table that behave, let's say, inconsistent. Okay? That is, sometimes they'll lose a certain number of electrons, and other times they'll lose more or less than that. Okay? Iron is a prime example. There are essentially 2 types of iron. The types of iron that lose 2 electrons when they join in a compound, and the type of iron that loses 3 electrons when it joins into a compound. Okay? One is far more common than the other, but they both exist. Okay? here's the problem with that. Because iron can behave that way and lose more than or lose like 2 electrons or 3 electrons in a compound, this compound here and this compound here would have the same name. Is that a problem? Well, I'll tell you, it is. I once had 2 Chase Andersons in the same class. It was a bit of a problem because they were not the same person. First name, last name's the same. Okay? It was a bit confusing. In fact, I'm sure I screwed up their marks for a little while before I figured out which one was which. Okay? It's a problem. Okay? It could be a problem here as well. Okay? Because, let's just say hypothetically, this stuff is rust and this stuff is highly poisonous. Okay? If I'm writing a paper about the health benefits of getting your iron up by licking rusty nails or something silly like that, okay, I'd better make sure I'm talking about the right thing. If I just write it's iron oxide, somebody goes out, gets this stuff and dies, I'm somewhat liable for that. Okay, are we seeing the problem now? Okay, or maybe one of these is perfectly harmless and the other explodes in the presence of oxygen. I don't know, like there could be something like that. Okay, obviously we can't have 2 compounds that would have different properties have the same name. That's going to be an issue. Okay, so what we have to do is we have to put Roman numerals in the name so that people know this is the iron that loses 2 electrons. This is the iron that loses 3 electrons. Okay, so we put in a Roman numeral in order to tell people that in the name. Okay, so how do I figure out which Roman numeral to put in there? All right, well, here's how I do that. It's kind of like, it's using the swap and drop, but it's kind of like using it backwards. Okay, so if I look at iron, and then I look at it on the periodic table. So if you look at it on your periodic table, you'll see there are 2 charges beside it. Okay, a +2 and a +3. Okay. Now, the +3 should be listed first. Okay, on your periodic table, is it? Okay, because it's the most common of the 2 types of iron. Okay, the +2 charge is much less common. Now, if I want to figure out which iron I'm dealing with when I'm looking at this formula so that I can write its name like this, okay, what I do is I look to the nonmetal. Okay, I don't know what the charge is on this iron yet, but I can use the nonmetal to tell me. Because if you look at your periodic table, there are no nonmetals. There's nothing to the right of the staircase that has more than 1 possible charge. Okay? There's only the multivalent metals that are like that. So the charge on oxygen is always -2. Okay? So the charge on oxygen is always -2. And all compounds have to have an overall charge of what? The positives and negatives have to cancel each other out. So if I have 2 negative charges here, then the charge on this iron, is it 2 or 3? 2. Okay, so that's all I do. I just make sure that my positives and negatives balance, and now I know this is the iron that's the 2+, so I write its name with a Roman numeral 2. Okay, that tells people when they're just reading the name and they don't see the formula that that's the formula they should use. Right? If I was looking at this one, okay, lead has 2 possible charges, 2 and 4. Okay, which one is this one? Okay, what's the charge on chlorine? No, what's the charge? If you look on your periodic table, the charge on chlorine is -1. Okay, how many chlorines are there? There's 2, so that gives me a total of how many negative charges here? 2. All right, so I've got 2 negative charges here. If this compound's going to have a net charge of 0, the charge on lead must be +2. All right, now I would write lead 2 chloride. Okay, try that. See what you get. Okay, I want you to write the name of that one with the correct Roman numeral. Okay, so SN stands for tin. Okay, what are the two possible charges for tin? 2 and 4. Okay, just like lead, 2 and 4. All right, so tin can be a 2 or it can be a 4. Okay, this stuff is sulfur, so it's going to be tin something sulfide. I'm going to have to put a Roman numeral in here because tin has more than one possible charge. And again, we only do this for metals that have more than one possible charge. I don't do this for all metals because I don't need to. Okay? Now, what I need to do is figure out which Roman numeral that's going to be, what the charge on tin is going to be. So I look to my non-metal. What's the charge on sulfur? -2. Okay, there are 2 sulfurs, each one with a -2 charge. So how many negative charges do I have in total? 4. Okay, I only have 1 tin atom here, so it must have a charge of +4. That's the only way that this compound comes out to 0. So this is tin 4 sulfide.
What happens if they like mixed a compound where there was like an extra charge?
Extra charge.
So when
Like where it wasn't balanced?
Yeah.
Then it wouldn't be a compound. A true compound does have to have a charge of 0. But you could get complex ions, which if you look at the top of your periodic table, there's a box there that says table of common polyatomic ions. Though that's kind of what you're asking about there. You can get things that go together, but they don't end up balancing their charges. So they end up behaving, most of them, like non-metals with a negative charge. Okay, so is this idea here kind of making sense? Okay, I mean, it's a little tiny bit of math, right? I mean, you got to do like a little bit of multiplication and division, but it's not difficult. Okay, we just have to look to the non-metal, figure out how many negatives, make it work with the number of positives that we have, figure out the Roman numeral. Okay. All right, I want you guys to try the first 4 here, and then we'll go through them together. Here anyway. All right, so for number 1, okay, I've got iron with oxygen, so I'm going to write the 2 names before I figure out what the Roman numeral is. And it's going to be iron something oxide. Okay, what's always the charge on oxygen? -2. Okay, how many oxygens do I have? 3. So I have how many negative charges? 6. Okay, so I just take the charge, I multiply by the number of atoms. Okay, that's going to be 6 negative charges. That means I need to get 6 positive charges out of the 2 irons that I have here. That means each iron must have a charge of. Okay, so I just divide the 6 by the 2, I get a +3. This is iron 1, 2, 3 oxide. It's kind of like finding the lowest common denominator for fractions or something.
What if we don't like know all the Roman numerals?
Oh, what if you don't know all the Roman numerals? Okay, you're not likely to need to know past 5. I think there's only a couple elements that have a charge of more than 5. Okay, so 1, 2, 3. IV is 4 because it's 1 before 5. V is 5. This is why the Roman Empire fell. The numbers sucked. Okay, and then VI is 6, and VII is 7, VIII would be 8. Okay? Just watch movies with sequels, especially the Star Trek movies. They all have Roman numerals. Or Rocky. All right, for number 2 here, I've got cobalt and sulfur. So it's going to be cobalt something sulfide. Okay, I need to look at cobalt. Cobalt can be a 2 or a 3. Okay, sulfur is always a -2. So what is the cobalt got to be then? 2. Right. So this is cobalt 2 sulfide. Okay. Now we've really done 3 and 4 as well. I'll give you a minute here and then we'll do 3 and 4. Let's have a look at 3 and 4 here.
Yeah. So for number 3, we've got Mn, which is manganese. Okay, and it's with chlorine, so it's going to be manganese something chloride. Okay, what's always the charge on chlorine? -1. Okay, so chlorine's always a -1. There are 4 chlorines, so I have 4 negative charges here. I only have 1 manganese to get 4 positives from, so the manganese must be the manganese with the 4+ charge, right? And so this is manganese IV chloride. Okay, and then last one here, we got copper with sulfide. Okay, and sulfur's always a -2, so that means this must be the copper with the +2 charge, copper 2 sulfide. Okay, making sense? Have you practice a couple here, and then we'll move on to something else. Okay, so I'll give you a few minutes on those last 6 there, and then we'll go through them. Okay, so for number 5 here, we've got Sn, which is tin. Okay, the possible charges for tin are 2 and 4, right? Okay. And then we've got it with tellurium, so that'll be telluride. We just have to figure out what Roman numeral is going to go here. So tellurium has a charge of -2. Okay, so if each tellurium has a charge of -2, and I've got 2 telluriums, that means I've got 4 negative charges in total. I only have 1 tin to balance that with, so this is the tin with the 4+ charge. Okay. Everybody with me there? All right, for number 6, Hg stands for mercury. And At is astatine, so this is mercury something astatide. And astatine has a charge of -1. Okay, there are 2 of them here, so this is 2 negative charges in total. There's only 1 mercury here. It has a charge of +2. Questions on that one? For number 7, we've got Po, which is polonium. And it's with iodine, so it'll be polonium with a Roman numeral and then iodide. Okay. Iodine has a charge of -1, and there are 4 iodines, so that's 4 negative charges in total. There's only 1 polonium here, so its charge must be +4. Okay, so polonium IV iodide. Okay, for number 8, we've got antimony, which is Sb. Okay, with sulfur. Okay. Sulfur has a charge of -2. Okay, there are 3 sulfurs here, so I have a total of 6 negative charges. I've got to get 6 positive charges out of the 2 antimonies. So what's the charge on each one of them? Okay, that's about as tricky as they get, right? When you actually have little numbers on both elements. Question?
Will this be on the quiz tomorrow?
You know what, I haven't decided. I'm going to see how it kind of goes today before I decide whether I'm going to put naming on the quiz tomorrow. There's a possibility there could be a couple, but they'd probably be basics. Okay, for number 9, right, we've got nickel with nitrogen. Okay, so we have nickel something nitride. All nitrogens have a charge of -3, okay, which gives us a total of 6 negative charges. So I've got to get 6 positive charges out of 3 nickel atoms. 6 divided by 3 is 2, so each nickel has a charge of +2. Okay, and then finally we have ruthenium with oxygen. So we got ruthenium oxide. We have to figure out which Roman numeral goes on here. There's 2 oxygens, each one with a -2 charge. So this is the ruthenium with the 4+ charge. Okay. Just takes a little bit of practice, but it's not terribly difficult. Question?
How does the 10 work? Because Ruthenium only has the prestige charge.
On your guys' periodic table, yes, because they changed that, and I forgot to change it back on this periodic table here, which is the one I used. Ruthenium can be a 2, a 3, a 4, a 6, or an 8. Yeah, so yeah, sorry. On your periodic table, they did take those other ones off. All right, any other questions on those? Okay, there's one other thing we can run into that you wouldn't have done in Science 9 with ionic compounds. And that would be when you run into a compound like this. How many elements are in that compound? 3. Sodium, oxygen, and hydrogen. Up until now, every compound you've ever done only had 2 elements in it. Okay? So this one contains something called a complex or polyatomic ion. Okay, remember that little chart I was talking about before that's at the top of your periodic table? The table of common polyatomic ions? This is where that comes into play. If you ever end up with a compound that has a metal to start and more than 2 elements, it has a polyatomic ion in it. All you have to do is look for that part of the compound in the table of polyatomic ions to find out what its name is. Okay? So, what's the name for Na? Sodium. Okay, if we look in our table of polyatomic ions, we should find OH in there somewhere. Okay, and OH stands for? Hydroxide. So actually, naming these is really easy. You don't have to remember anything except to look for it and find the name. You don't have to change it to any other ending. It's just the way it's written there. Sodium hydroxide. Okay? If I had this stuff here, it would be, what's NO3? Nitrate, right? Okay, these ones I don't change to end in I, okay? I just write them the way they appear in the table. Okay, and we also could have something like this. That stuff be. What does Ca stand for? Calcium. Okay. And we just had the OH on there. What was OH? Hydroxide. Okay, we name these just like any other ionic compound, metal and then the non-metal essentially. Okay, this is the non-metal because it has a -1 charge. If you look beside it on your table of polyatomic ions, it's written like this, OH, and it's got like a little negative beside it. That means its charge is -1. It behaves like any non-metal with a charge of -1, like chlorine, like iodine, any of those. Okay, why do I have brackets around it? I wouldn't do this, would I? No, I wouldn't do that. It doesn't make any sense to do that. Okay, because that is just one element. I would write it like this. But this is an ion that contains 2 elements. If I write it like this, it tells me that there are 2 hydroxides. If I write it like this, it's 1 oxygen, 1 calcium, and 2 hydrogens. It's not the same thing. Okay? So if you ever have to, when you're doing a swap and drop, put a number beside a polyatomic ion, you have to enclose it in brackets. So it's kind of like order of operations. This too applies to everything in the brackets. Okay? We'll get to that. It's not a big deal. You just have to remember sometimes you need brackets. All right. So let's talk about molecular compounds next year. I'm going to give you a little break though.